And of course we could have curves in polar form as well as in Cartesian form. And we have a formula given here to deal with finding the length of a curve in polar form. That involves r's and theta's as opposed to x's and y's. And we're going to do an example for a cardioid. So here's our equation for a cardioid. Have a look back at the notes on polar form and the curves if you want to have a check what that actually looks like. But it's a cardioid, and it's got the variables in our r and theta. So the first thing we're going to need to do is differentiate this thing. So we need dr d theta. So if we differentiate this thing with regards to theta, we're going to get a derivative of cos is negative sine, so negative theta will be positive sine theta. So that's our derivative, and then we can just bung everything into our function. So s equals the integral from the limits, which are from 0 to 2 pi, of the square root of r squared, which will be a squared 1 minus cos theta squared, plus the derivative squared, so that'll be a squared sine squared theta, square root, or d theta. Okay, so what have we got here? We've got an a squared in common, so we can pull that right out the front of the whole lot. So we get a 0 to 2 pi, square root, expand this brackets, 1 minus 2 cos theta plus cos squared theta plus sine squared theta. Cos squared theta plus sine squared theta is 1, and 1 and 1 is 2, and we can take that 2 right outside the square root. So we're left with root 2a, 0 to 2 pi, square root of 1 minus cos theta d theta. Okay, so then we've got to figure a way of integrating 1 minus cos theta and the square root of it. So the simple thing is to do is to make that standard trig substitution. So we get root 2a integral from 0 to 2 pi, and 1 minus cos theta is the same as 2 sine squared theta over 2. And that's obviously all to the power of, it's all square rooted. If you're not sure about that, look up your formula sheet for trig substitution, one of the standard ones. And now I'm going to take this root 2 out the front as well, so root 2 times root 2 is just 2. And then we're going to be integrating, what have we got left? Square root of sine squared. Well, that's fairly easy, it's just sine. And if we do that integration, we have 2a. If we integrate sine, we get cos. In fact, we get negative cos, and we've got to deal with that a half with a 2 as well. 0 to 2 pi. Let's take this negative 2 out the front, so we've got negative 4 cos 2 pi over 2 is pi, minus cos 0. And the cos of pi is, cosine goes that way, so it's negative 1 minus another 1 is negative 2 times negative 4 is 8a. So the length of our curve is 8a, which is kind of nice that it's still got a in it, because the actual shape is going to depend on a, and the length of that curve will be 8 times whatever a is.